Welcome to section 13.2. We're looking at recursive sequences, recursive routines with sequences. And so I'm going to just basically go through a couple of examples, just getting used to the notation, looking at an arithmetic, a geometric, and then I think a neither example. So the first one here, we're looking at our recursive routine of t sub 1 equaling 2 and t sub n equaling 3 times t sub n minus 1. So the goal is just to figure out what are the terms in the sequence. We know the first term in the sequence is 2. We want to find the rest. So if we're looking for t sub 2, the idea here is then that our n value is 2. So we're looking at 3 times t, and so n is 2, so 2 minus 1, which is really just giving us 3 times t sub 1. So recursive routine, the idea is that it's always based upon a previous term in the sequence. In this case, it's based upon t sub 1, what that is. Well, we know that t sub 1 is just 2, so our second term in the sequence is really 6. Now, sometimes when you're using a recursive routine, you'll notice a pattern, and once you start noticing it, feel free to use it to figure out your sequence. But just to get used to the notation, we'll do one more. So t sub 3 is equal to 3 times t sub 3 minus 1, which if we simplify, is really just t sub 2. Now, we already know what t sub 2 is. It's 6. It's the previous term that we just found. Excuse that announcement there, if you heard it. So t sub 2 is just 6. So if we do 3 times 6, we get that our next term is 18. Now, if we were to start listing our sequence, again, you can keep doing the same thing with our notation to get the rest of the sequence. But we've got 2 for the first term, 6 for the second, 18 for the third. Now, you might notice that there's a pattern there. This idea that we just keep multiplying each successive term by 3. So if we would extend that pattern and find the fourth and the fifth term, we would then get our next one as being 54, so the fourth term, and then multiplying again by 3, we'd get 162 for our fifth term. So there's the terms in our sequence. Now our next job is to identify this as arithmetic or geometric, and then look for the explicit definition. Well, in this case, we definitely have a geometric, because we have this constant ratio right here of 3. So using our geometric sequence, so definitely looking at geometric, oop, too far. All right, so let's write our equation then. So the explicit one is just we talked about in 13.1. So we're looking at t sub n equaling t sub 1 times r to the power of n minus 1. So based on our information, we know that t sub 1, well, is 2 from earlier. So going back to our earlier information. And we now have figured out that our constant ratio r is really just a 3. So plugging that information in, we get that t sub n is equal to 2 times r to the power of, not r, 3. There we go, our constant ratio to the power of n minus 1. And now a lot of the times we do just clean that up because we like to have just n as our exponent. So if we clean that up, we'd get t to the power of n, t sub n equals 2 times 3 to the power of n. So breaking up that exponent, and 3 to the negative first power. So that 3 to the negative first power we can rewrite as 1/3. So if we rewrite that as 1/3, we're really getting that t sub n is going to equal 2/3, so 2 times 1/3, and then times 3 to the power of n. So that right there would be our explicit definition for this sequence. We see both the recursive at the beginning and then at the very end here, our explicit definition. All right, so there's the first example. Feel free to start into the homework or look for the next example on my next video. Thanks for listening.